The main properties of aluminium are known to be lightness, good thermal and electrical conductivity, mechanical strength, plasticity and malleability, and excellent resistance to atmospheric agents. Its optimal resistance to corrosion, even in the raw state of production, is made possible by the formation of a uniform layer of natural oxide that passivates the metal's surface, thus creating a barrier against external, aggressive agents. Aluminium may be made even more resistant to corrosion with opportune surface finishing treatments that also contribute to its improved appearance. The surface treatment par excellence is anodic oxide, which for many years was the most widely used in the various applications of lightweight aluminium alloys. The end of the last century saw a notable increase in the use of painted aluminium, which in certain sectors, such as construction, has reached a position of absolute primacy. This finish has gradually been enriched with new and interesting solutions, such as metallic colors and decorations able to perfectly replicate the grain and the vein of other materials, such as wood and marble. Today, with the use of coating, it is possible to satisfy even the most difficult-to-please users by formulating new colors and adapting them to every type of environment. In Europe, the painted finishes for aluminium used in architecture are used by powder coatings. From the beginning of the 1980s to the present, the use of this type of finish has increased greatly, above all in Italy, Germany, Spain and France. This increase is due above all to the ample availability of colors, the consolidated coating processes, and the excellent qualitative and performance levels obtained with powder coatings. It should be added that the use of powder coatings has significantly reduced the impact on the environment and has also increased worker safety, since there are no complications due to solvent disposal. The process of powder coating includes 3 distinct steps: preparation of the surface by degreasing, etching, and deoxidizing with chemical conversion treatment. Application of the powder coatings, curing in the oven, before proceeding with the coating, the surface of the aluminium must be clean and free of grease, oxides, oils, and residues from previous processes. A normal cycle may include various phases of chemical treatments, with the use of specific chemical solutions, as well as mechanical treatments. After an initial degreasing, a subsequent etching can be carried out, followed by a neutralization deoxidization phase before the chemical conversion for the complete removal of the superficial oxides. All these phases are alternated with adequate rinsing phases that ensure the complete cleaning of the pieces. It is important that with these preliminary treatments, a superficial layer of at least 1 gram per meter squared be removed, in order to obtain an efficient chemical conversion of the surface to be coated, which results in better adhesion of the coating on the aluminium and greater corrosion resistance. The chemical conversion treatment consists of a chemical process carried out on the surface of the piece that is immersed or sprayed with solutions of various chemical compounds able to interact with the aluminium and form a layer on the surface consisting of metal oxides and possibly of organic components. The treatments used are the following: chromating, phosphochromating, hexavalent chromium-free treatments based on titanium, zirconium, trivalent chromium and organic resins, anodizing. In the past, chromating was the most widely used chemical conversion treatment. During this process, iridescent yellow or opaque yellow hexavalent chrome oxides form on the surface of the aluminium. The presence of hexavalent chromium in the solution and on the treated piece makes it increasingly difficult to comply with the legal requirements for its use. Phosphochromating is also widespread in the sector. In this case, the conversion layer is composed of oxides and phosphates of trivalent chromium, whose color ranges from pale green to iridescent green. In this case as well, the presence of hexavalent chromium in the solution is making its use more difficult. The process is based on titanium, zirconium, organic resins, and trivalent chromium, are more widely used today than in the past, partly due to the hazardous classification of hexavalent chromium attributed by European legislation and implemented in all EU countries. The processes without hexavalent chromium, depending on the chemical nature of the compounds used, lead to the formation of a conversion layer based on aluminium oxides, fluorides, and complex oxides of titanium, zirconium, organic resins, and trivalent chromium, which is usually colorless. The formation of a thin layer of anodic oxide is able to perform the same functions as the layers of chemical conversion previously described. Some technical and economic problems, in any case, reduce the possibility for its use. Naturally, for applications of this kind, appropriate conditions for anodizing must be established. In particular, the oxide layer must not be sealed. After every phase of the surface pretreatment process, appropriate rinse cycles must be carried out to remove the residuals of the solutions and avoid contaminating the subsequent phases. The final rinse after the chemical conversion is very important. This must be carried out with demineralized water, except in cases in which the no-rinse conversion technologies do not require it, as it must eliminate all of the salinity from the surface that could generate defects and corrosive phenomena under the subsequent coat of paint. At the end of the pre-treatment sequence, there is a drying station for the pieces. In this step, using air at a temperature of about 70 to 100 degrees centigrade, depending on the conversion treatment used, the water is eliminated from the pieces, and the conversion coating is completed through dehydration of the deposited layer. The wastewater from the various pre-treatment steps must be conveyed to the sewage treatment plant before being emitted into the municipal sewer or the surface waters, respecting the composition limits imposed by current laws. The vapors produced during the various pre-treatment phases must be monitored and kept below the threshold levels set for work environment emission into the atmosphere. The noise level within the facility and outside it must be measured with the appropriate instruments and brought below the threshold limits. The most widely used method for applying powder coatings is spray, which consists of spraying the electrostatically charged powder onto the support to be coated, which is placed in an electrical field and grounded. Today there are various techniques that use either a spray gun or discs or rotating cups, to name a few. All are capable of ensuring a regular, uniform deposit of powder, good penetration for the various forms of the sections, and a fairly simple and rapid change of color. The cycle that leads to curing is one of the most critical steps within the coating process. The formation of the compact film passes through three distinct phases that follow one another as the temperature increases. Melting, film formation, and curing. Hot air convection ovens are generally used to execute this cycle. The powder coatings used to paint semi-finished, extruded and laminated materials for external use are mainly of the thermosetting type, based on a polyurethane or polyester binder system. In addition to the traditional shiny or matte monochrome finishes, over time, other types of finishes have gained popularity. For example, metallic finishes, particularly pleasing from an aesthetic point of view and obtained by dry mixing of powders with metallic pigments or micas. Finishes with textured effects. Other pleasing variations of the aesthetic appearance of powder films may be obtained by modifying the structure of the film itself, which can take on textured and veined effects. Marbled effects, obtainable by mixing more than one colored powder, thus creating a multicolour speckling. For 15 years, it has been possible to create effects and finishes that imitate the veining of natural materials, as wood and marble. Today, these finishes represent a large portion of the market. They may be obtained with two main technologies. Sublimation, which consists of reproducing any effect or drawing that was previously printed with special inks on plastic or paper film, on a contrasting base of ground in already cured powder. The technique takes advantage of the property of sublimation of some inks that are able to penetrate in the powder coating film under particular temperature and pressure conditions. The other technology, called powder on powder, permits the realization of the decorations with various methods. Basically, on a first partially cured base layer, one applies a second coat of a different color that, with appropriate equipment, takes on the definitive pattern. Finally, the two layers of paint are cured according to the instructions of the supplier. To get a complete overview of the performance requirements of a powder coating, one must refer to various characteristics: visual, mechanical and technological, chemical and chemical-physical. The visual characteristics are all those having to do with the appearance of the paint layer, that is, the uniformity of the layer, color consistency and gloss, and the absence of defects, bubbles, swelling, scratches, etc. The mechanical and technology characteristics include a group of properties such as the thickness of the coating, the hardness and adherence of the film, its resistance to abrasion, bending, impact, and drilling. The characteristics of durability refer to the performance of the article when subjected to atmospheric agents or an environment saturated with industrial gas, marine environments, and when exposed to solar radiation. The installation of windows must be carried out according to precise rules, which must be strictly adhered to. In particular, the installer must ensure that there is no direct contact between the frame of the fixture and the fresh masonry, or the frame and the footing. The continuity of the insulating layer between the wall and the frame must avoid thermal bridges and minimize condensing phenomena. In any case, it is essential that the builder be told that the masonry, as a result of atmospheric agents, must not cause infiltrations of water and must not transfer moisture to the fixtures. With the term maintenance operations, we refer to the cleaning operations that must be carried out on the coated windows, characterized by the following factors: frequency, timing, and products used. The decision about frequency depends on three fundamental factors: accumulation of moisture, duration of this phenomenon, the degree of pollution, presence of quantities of dangerous pollutants such as sulfur dioxide and industrial smoke, etc., and the chloride content, above all if near the sea. Once frequency is established, it is a good idea to carry out the cleaning operations after the periods in which the factors listed above are most active. For the choice of cleaning products and their application, it is important to keep the following warnings in mind. Avoid acid or alkaline detergents, abrasive materials, organic solvents in general, detergents of unknown composition, and steam cleaning machines. During the cleaning process, do not expose the sections to direct sunlight. They must be kept at a temperature of about 20 degrees centigrade. Avoid using cleaning detergent that's either too hot or too cold. The temperature of about 20 degrees centigrade is best. Bear in mind that the facade is also composed of other materials. Therefore, the choice of detergent should be made taking into consideration the action that it can have on the latter. It is thus extremely important to ensure that the customer receives detailed information about cleaning procedures in order to avoid problems due to a lack of competence and inexperience. The internationally recognized quality label of coated aluminium is Qualicoat. Qualideco, on the other hand, is the quality label for decorated aluminium. For applications in marine environments, the Qualicoat label provides for the seaside extension, which requires removal of a minimum of 2 grams per meter squared of aluminium before the chemical conversion. The labels consider the entire chain of production, from the producers of raw material through the applicators. In Italy, the entity that certifies the labels is Qualital, located in Cameri in the province of Novara. Every request for delivery which must be received in writing must refer to a specific technique that defines all of the characteristics of the coating. In particular, the fault points must be specified. Color. Using the RAL color codes and corresponding reference sample agreed upon between the customer and the supplier. Color consistency. In accordance with the provisions of a specific technical data sheet from the ITAL Association regarding the limits of acceptability in color variations. Gloss. The same as that of the agreed upon sample and with maximum variations in accordance with the Qualicoat label.